Hello there, and welcome to Weekend's Web App. This is day 13. We're building a web app, as has been said on previous streams, and today we're going to be going into IndexedDB. If you want to follow along at home and you've got the repo, you'll want to use Git to check out day 12, because that's where we finished last time. And yeah, that'll bring your code to exactly where we are right now. So last time we started doing some play with IndexedDB. We're still in our exploratory phase, and we will be for some time. And we got some basic stuff in place that allowed us to get information by key, and also get all information by key. So if we take a look at how things are here on the app, we're using Firefox today. You'll see that we bring down our entries. Now those entries are old, they're a bit stale, so what I might do is delete the database and get the new elements of the database in. It might come about time that we actually do this by default before we run a database, just so that we can start to what's the right word to say it? Just so that we can actually get these databases cleared every single time, so that we're always starting with a fresh load of data, because in this development phase we don't really want to hang any of that data around. Anyway, let me do just what I need to do. So I need to, in here, I need to take IndexedDB and delete database www data. That'll probably be done by now, and now I can uncomment this. And that should give us our running query. There we go. Yep. So we got our data in there. Okay. That's good. And what I'll probably do, I won't do it this stream, just because it'll be a bit of a distraction from what I really want to talk about. But probably next stream I will set up something that will delete that database ahead of this initialization step every single time, so that way we don't have to keep on going back and reworking the database. We can just clobber it or delete it, whatever you want to call it, and every single time it'll just start with a new database, and that way things work as we expect them to. Anyway. So you can see here, we've got our entries. This is the result of a get all, and the result of that comes out as sort of an object with all the, an array with all the objects, and that's good. Works as we want it to, and then we just stick them into Redux. So if we go and have a look at our Redux tool, you can see that the content actually gets put into there. And that's not just the content itself, but the authors. Not just the articles rather, but the authors as well. So yeah, that's all the way back there. So near the end, this is where we've got the full line of content after all these put content calls. And as we go in there now, every time it's we're still calling IndexedDB every single time we get into these new places, which is fine. We might want to eventually make that more efficient, but like as I said, this is really about getting IndexedDB correct than it is about getting We're here so that we can build a proper layer that we can build the real app on. This is not the real app. So let's talk a bit more about what we could do for a real app. And one of the things that proper databases have is a thing called queries. And what like a query just allows you to say certain things and get particular things in response. So at the moment, we've just got two very simple statements. If we look in app.ts, we're either getting a particular entry. Let me find where I can grab this. Yeah, here. So home. Here at home, we're getting all of the things and putting them in. So we get everything from the database, and then we put it in the various places that it needs to go. We use put content. And then if we look at the entry, we're getting a particular where do we go for this? Right, sorry. I was just just glazing over there. Okay, so here we're getting by key a particular article, and then after that we get by key a particular author, and then we have everything that we need, and then it returns. Now, what if we say wanted to have an author page? Well, let's start off with that. Now, I want to use talking about queries as sort of an introduction into like we always want to be writing usage codes first. I'm sure you've started to pick that up as a general trend, because we want to be able to talk about what it is precisely that makes our code tick. We want to talk about how we want to use the code, and not just how we want to we want to talk about how we use the code, and not just how we think of it in a conceptual way, because it's a lot easier to actually try your ideas out than it is to just think about your API for a really long time. So that's what we're trying to bridge that gap of. So we're going to create a new route to sort of test this theory. We're going to make a route for authors. Okay. So instead of this get by key for articles, instead we're going to use the slug. It's more of an ID, but anyway, it doesn't matter too much. Yeah, we'll call it ID because it is author ID. It's not a slug. Okay. And what we'll do is we'll take it so that instead of all of this stuff happening with regarding articles, we're going to instead use params.id to be our key. And then after that, we can remove this statement, because literally the only thing we have happen is we have our author come back, and when we stick it into the store. And now we actually have to render this little view. So I'm just quickly smashing through and getting this ID here, and grabbing that from outstate. And then you can see here, we just need to update this view to look a bit more like what we want it to. So if I've already forgot what the author state looks like, it's just got an ID and a full name. So let's go author.fullname here. And then we really have nothing else, because eventually, well, we don't have all the articles that are related to this particular user or anything like that. So we, related to this particular author rather. So we're going to create that, and in order to get to that page, we could just manually do it, but let's add ourselves some links in the home page. So we need to get all of our authors, and we'll just do it this way where it uses object keys. Won't bother sorting them just for now. It's not oh, it doesn't take much. We could sort them. Let's sort them alphabetically. Authors, and then we'll sort them out. Same deal as this, except using full name. So now we've got our authors, and yeah, so we were talking about, don't mind me. I was going to talk about mapping state and stuff like that, but it's not a sensible thing to do at this point. So anyway, we've got this author, and we just need to have an author's render as well. Unfortunately, this is just typing. I'm just smashing through it as quickly as I can. Why is author? Duplicate identifier author? Where is the duplicate identifier? Because yeah, it's in here, but that's contained. I'm not sure. I'm just going to, it's probably this one. Yeah, it is that one. Okay. Right. So we need to go to the author page, and the ID of it is author.id. I'll just go for author full name. That should be enough to give us our list. So I'll have the authors render here, and I'll just put a separator between them, just a horizontal rule. That's what that stands for, HR. And if we reload, we should see our authors. You can see we have 3 authors. We have 4 articles. Anyway, if I click on this one here, that brings us to the author page, author 0, and you can see it loaded up the author. It loaded up the author there. It put content in, not that it actually changed, so there was no actual change. And you can see there, Jane's Rackage, Jane Blogs, etc. So there's our basic route, right? So we've got our author collected here. And that's all hunky-dory, but we want a bit more than that. What if we want the actual articles that are related to this author so that we can list them out? Well, if we're going to do that, then we sort of need to have some sort of way to do a query. So if we look at this context.db.getByKey, we need to have some way to put some sort of query onto this, like to determine how it is that we're going to get what we need to get. And like the troubling thing with this is like we can't really do complex queries with IndexedDB. Just not possible. They don't work. But what we can do is we can do some basic queries and then piggyback off that like first basic query to then do some more complicated logic, because all of these things result in what's called a cursor that lets us sort of check things. But I am getting a bit ahead of myself. So how about we do the simple case first, right? And talk about what it is that is going to get us through to the next sort of stage of this. And realistically, that next stage is going to involve some sort of behavior that allows us to do to filter against, say, some set of rules. Okay. And if we look at, like, there's a lot of different ways that people sort of approach this, because this is what's called statement mapping in a lot of cases. Like, you want to give it some rules, and then you just want the thing to return what it is you want for us. And if you're talking about SQL, SQL, if we have a look at, yeah, it's probably time to have a look at some prior art in this one. And what I'm going to do is look at, say, Django. So Django is a web framework that I'm pretty familiar with, and let's have a look at that, how they do their queries. And note that, like, I'm not saying this is a good thing, bad thing, or anything like that. I'm just saying, like, this is a way that they do queries. So let's jump past all of that and go to retrieving objects, because this is what we're really talking about. We're not talking about creation where there's just one thing, and we're not talking about retrieving all of them or deleting or anything like that. We're talking about, like, how do we get particular things? And they have this concept of, okay, they have this manager called objects, okay, and that manager could be just like, say, we set things up so that underneath DB, you've potentially got something like authors or something like that. Like, that could be our manager, say, right? And that way we don't have to put authors here. And then after that, you've got this concept of .all, which means essentially get all of the things. But you can chain these with all sorts of different things. So here you can see it's got .all, and then they filter it. And filtering would be to say, okay, now after you've gotten all of the things, I want you to go over all of the items and filter against them. And what happens is eventually you chain all these different things together. So you've got filter, and then exclude, and then maybe filter again if you wanted to. And it eventually, behind the scenes, it figures out what to do, what is the right SQL or SQL to write to get all of this information out the right way. And it can start to get very complicated. And part of what makes Django complicated is it also does things underneath, like it automatically goes and gets relationships and that kind of thing. Another thing that I've played with is Elixir, or it's another programming language. It's one of its main ways you handle databases is called Ecto. And if we were to look at their query approach to queries, let's take a look at that. So here they approach it just a little bit differently. And what they do is they create a query and then they feed that into a database. And the idea of that query is it can sort of be constructed in like that. Like they have this it's not quite a domain specific language, but it's certainly like it looks a lot like it. Oh yeah, no, let's call it a query. Let's call it a DSL, even though it uses a lot of what Elixir allows you to do and just sort of skirts over the spaces and whatnot. But anyway, so that domain specific language, we'll call it that, allows them to sort of make things that look a lot like a SQL query and then reuse that query and then just throw it at the repo whenever it wants. And then after that, they have methods that can ask for certain things to then get preloaded based on the query. Let me see if I can find... Is there anything about preloads here? So yeah, it can also give commands to preload sort of things that depend on other things as well. So that can be useful as well. So maybe what we... and trying to find the right way to approach this, I think the thing about IndexedDB is just because of the nature of it, I find the chaining API is potentially, the chaining API sort of demands that I have something at the end that says, okay, go. Like you do filter and then exclude. So let's say we're filtering by authors and it's like, or rather, say we're filtering articles. And you go, all right, I want the author ID to equal, say, author.id here. And then we exclude something, I don't know. I mean, technically we wouldn't, but let's say that we did have some sort of exclusion, like, say, the publication date less than, say, less than today. No, like a year in the past or a month in the past or something like that. So maybe we put a date in there, like 2018 06 10, which is a month in the past, right? So we're only getting recent articles, or you could also make that a filter of anything with a publication date greater than, say. And this is sort of stealing off a particular way that Django allow you to make queries based on certain things. You can see that here, where it's got the field name here, and then their double underscore allows them to then do some sort of logic, such as greater than, starts with, and so on. So say you did that, and I'll just change that back to an exclude to make it clear that it's something different. So say you did that, and then eventually you would need something to sort of tell it to go, right? So it might be something like evaluate, or if you did a then on it, then that could trigger it to go as well. So that's a couple of things that could happen to it. Both of which, while chaining's nice, I'm not sure if I want to do that anymore, and I want to play with more of a schema that sort of you can create the queries and it just goes ahead and does it, and you can create these queries single times and then potentially keep on reusing them, or at least create them in functions and have it easy so that you can actually read what the query's shape is and stuff like that. The other thing I don't want to do is I don't want to have to put the string name here. I feel like no matter what, you're always going to be querying against a specific thing. So it probably makes sense that, you probably don't even need to do that. We could just have something like query, and then in it, we have some sort of query. And what would the shape of that query look like? So maybe, and this is where it gets tricky, because I don't want to do a DSL or anything like that. Domain-specific language is kind of gross and kind of ends up like, I'm reminded of a particular reference about a DSL, which is it's a language that allows you to write code in one language and receive errors in another, which is totally true because it means that you're not getting errors that are actually in the domain specific language or anything like that. So what we would probably want to do is figure out a way to encode concepts like this into some sort of object that we could call that query object. So what could a query object look like? Or maybe it's more like a list, right? But let's say we've got a query. And it would probably be against a store every time, right? Say articles. And because of the way things work, and because we can really only filter on one specific thing as our sort of our main key, maybe let's think about IndexedDB as a means to do this, rather than thinking about how SQL does it, right? Because we can't do it like SQL does it. If we look at the documentation for IDB Object Store, you can see this concept. Let me see if I can. Okay, so you've got the concept of index, which allows you to get objects based on that index. Or you're going to open a cursor directly. And let's have a look at that index one, because that one's interesting. So if we've got an IDB index, oh no, that just gets the index. Yeah, so we'd need to get the index, but then we've got to make a cursor with some sort of key, and then we create that query. But that query is always going to be a rather simple thing. It's not really allowed to be anything that's too complicated. It can only sort of choose against one thing and do a greater than or less than or within a range. It's not a complex query with a lot of different things. But I mean, maybe we're getting ahead of ourselves and we should just focus on the simple case, okay? And maybe the filter is the only way that it sort of happens. Like we base it on a very particular shape, and we just give it its rules. Yeah. This is a tricky one because like I wanna figure out the right way to write this, but I guess this is the point. We need to write some usage code, right? So what if we could work over key, which we should have an index for. Let me double check if that's actually what ended up in the migration schema. Yeah, so we did add an index for author ID. And then after that, we would use a thing called IDB key range, which looks like this here. So this IDB key range allows you to say, all right, like particular ranges that you search over the keys. And it doesn't really, like you would notice that it doesn't really have a lot of nous to it. It has greater than, less than, in between, or equals. And that's all well and good, but that's not going to cut it in the long run if we need to do things by date sometimes, or the very particular like numeric stuff, or say we've got, say we want to show two authors and we want to have it be equal to one or the other, then we instantly have to look over everything in order to get all that information, right? So we're already we'd already be going into realms that go beyond this, but let's think of the basics, right? So we have some sort of key, so we have some sort of store, and then we want to run an operation on it to get certain things. And maybe it's better to think of it in terms of a sequence of operations, and then the system goes ahead and does it. Or maybe it's better to think of it as, okay, there is a base filter. So So it's going to be based on a key, or it's going to be based on the ID itself. So it could be based on ID or for ID in this case. And then after that, we want to sort of have that top level filter. So what could that top level filter be? So it could be whether it particularly equals something. So that one would look like have a type of equals or only as it says, and then the value would be, say, author.id. So that's potentially one way you could lay it out, and then eventually you could make some functions that sort of make it easier to build out these items. But maybe that actually needs to be here. So yeah, maybe that is it. We have a store and then we have a filter. Now, if we're going to do it that way, what else could we do to sort of increase the make it easy to increase the complexity and figure out whether filter is the right word even? Because essentially that's the first thing that's always going to happen, is you're going to filter on something. And sometimes that filter is actually going to be all, and then you got to do some more complex, like approach it more with more complexity after that. Yeah, I keep on finding myself back to some sort of thing where it's like, all right, we just need to go through and run it like this, because that is literally what the query is going to do. It's going to filter based on the first thing, and then the second things are going to be done on subsequent rules that have to have to work with our IndexedDB's API for it, just because of the nature of it. So maybe we'll just do that. We'll just run with filters and we'll see how that works. And then maybe that allows us to have something like, say if we picked up articles, like a bunch of articles and stuff like that, maybe eventually we could do some sort of preload for these sorts of things and then carry it on from there. I'm not totally convinced we want to go down that road just yet anyway. But let's say that is enough for us, right? That we could run a query on a database and that would theoretically give us everything that we needed. And then after that, we would have all the articles. And where do we have? Yep, that one will do. So we just... So after we get all the articles, we chuck all the articles in. And I'll put an any on that. And at that point, we are done. So the one big problem is we don't have something called query here. So if we try and run this bad boy, it's going to crash because context.db.query is not a function. Well, we're at this point. We may as well figure out whether this concept could possibly work. So if we go to db.ts, so I've kind of gotten away with, like, I was tossing up whether we'd actually define the schema. We sort of got away without doing it, and it's mainly because we know that we don't need the schema yet until we start dealing with relations. For the moment, we can just sort of accept that this information is true and correct. Eventually, we'll need to do validation against it, but for now, it's good enough. So we've got a query definition here, and we're going to have to create some sort of API for that, just to sort of make it clear how that's meant to go. And I'm actually going to create a new file for that. What am I doing? There we go. And the reason I'm creating a new file is because I know that this is going to explode in complexity in the near future. So let's export an interface. interface called query interface. And we're going to talk about what we put in it. So if we jump on up to where that query was, so it's going to have a store, and that's going to have a string attached to it. And we're also going to have an array of filters. We know that much. Yeah, we're going to have an array of filters. And for interface, and that's going to be a filter definition. And that's going to have the key, the type, would type be the right name? What do they call it in Django? I don't mind the word lookup. Yeah, I like that. Lookup's not a bad word for it. It also, because the word type is a pretty heavily used one in TypeScript, I kind of don't like using type. If I can do something that's a little more accurate, it's not the right word, but maybe a little more not necessarily accurate, but at least more descriptive than just a plain old just a plain old word type. Anyway, so this query interface, and it's probably better if I go for query definition, just like that. And then we've got a filter definition here, and we'll import those interfaces so we can make use of them. Right. So we're asking for a query definition here. And we're, of course, going to need to build off of the thisDB promise. And then we're going to have to do some stuff to get our store. Now, our store name will come from our query definition. It'll equal query.definition.store. And then we've got the object store, and then we need to run our request. And I know that I'm going to need an initial filter, right? So the initial filter, if query definition dot filters dot length is greater than 0, then it's going to be then it's going to be query definition dot filters 0. Else it's going to be well, nothing really. And for a while, I'm not going to handle this null case, but potentially what we'll do with an empty query eventually is we'll just treat it like an all. So it'll be the equivalent of using get all, just like this one here. But what we want to do is we want to turn that initial filter into a query. And when we do that, we need to sort of work with this IDB key range, this concept, to actually make use of it. And we can see sort of here the concept of opening a cursor on a key range value. And that allows us to iterate over a space that sort of evaluates a particular key and allows us to work over it. Now, there is faster ways to get things with object store. Like you don't have to iterate over everything. But the real problem is because of how limited this is, generally you just want to go straight to a particular case. And we can do those optimizations eventually, but I just sort of want to get to a place where we're doing this iteration pretty quickly. So if we have a look at the IDB key range as a concept, so we want to use that, we want to build that IDB key range and then make use of it to then do this work here. And IDB key range is something that you have available in the console, I believe. That's the one right there. And then you can create IDB key ranges of particular names and all that and work through it. So we need to handle that. So let me jump back to the documentation real quick. I'll just sort of glance over this as I'm going. If you want to keep an eye on this, then yeah, pull it up in your own tab or something like that. What I'm going to do is I'm going to make an only key in response to this, and I guess it's important that I have some sort of clear way to build these keys out on this end. So what I'm going to do is create a function, export a function that so create key range for filter, and it'll take a filter definition, take a definition, and return an IDB key range. So I may as well do that whole concept here. Just because I haven't returned one yet. Now, so if our definition has a lookup that equals, and eventually we could make this, we could tighten up our types on this and make that an enumeration. But for now, we'll just work it like this. So if the def lookups is key, and if we have a traipse on down here, you'll see that this bounds. That's unfortunate. So it's got this cursor, and because of this bounds, it doesn't actually place the key name inside the range. So we'd probably have to do a little bit more to get this properly set up. Anyway, let's carry on. So if the definition lookup equals lookup, then we go for an IDB key range, and we'll make it only, and then we have a lookup, def lookup def.value is what we'll use. So that's how we get our key range. So again, we've got some weak spots in this code, but we'll deal with them as we get there. So we want to create key range for filter. And that's initial filter there. Okay, and now what we want to do is we want to open this cursor, and when we do open this cursor, we need to base it on a particular key. Ideally, one of the ones that we've created. Well, it has to be one of the ones that we've created an index for. I'll try and blow up the query maker at some point and make it a query against something that is not in existence. Anyway, let's jump into Object Stores API and just remind ourselves of what function we need. Where'd it go? Oh, I'm in IDB Object Store, so it doesn't show up for me. Okie dokie. So here we've got open cursor, and it opens cursor with the primary key. And here open key cursor allows us to specify a specific key. And why does it not provide the key? I think we're going to have to open the index in order to do it. Yeah, there you go. Yeah. So we have to open the index for it. So, all right, it's been a while. Anyway, so what we need to do is open the object stores. We'll call it store here because that's what it is. And we get the index based on the name of that initial filter. So that initial filter dot key. And then once we've got that index, we can open a cursor on that based on the key range. So this will start to hopefully make a little more sense once we do this. So we've got a store request, and it's called .openCursor, and we're going to do it with that key range. Oops. My bad. Getting a little flustered. All right, let's get rid of that. Okay, we're just going to resolve for now, but I eventually, I need to show you what comes out of this so that we can go from here properly. ev.target.result. Yeah, that'll do. Okay. So I've just done this a little bit here because what we're going to need to do. So when we did that, and this success is actually a bad thing. Let's make it index cursor. Okay, so you can see index cursor called once, but we have two articles that are attached to this this author. So what precisely is going on? Well, it turns out that when we get a hold of our cursor, we then need to work over the space in order to actually get what we want. Even though event target result is not giving us what we precisely want. Let me just check that the database is correctly set up. We have articles, we have authors. Author ID is 1. Should be sufficient. Let me just double check that the query is right. And initial filter. We'll run that again. Okay, so we can see we've got an IDB key range in the lower and the upper are 0 because it just wants to choose only that one. So author ID equals that. And the index cursor, we might as well check what the index is, just see what we've got that. Oh, of course, I need to base it on index. That's what I did wrong there. So now we can see a few things going on here. So right here, this set of items is our IndexedDB, IDB index rather. Here's our key range, here's our object, our field filter definition. And when it gets into the cursor, so this is the event here, and this is the event target result. So you can see here we've got ourselves a value, all right, which is at least one of the items that has what we need, and then this source, which is this index, this IDB index. And it's also got a direction, because what happens, and actually this does give me a chance to write things down. I didn't think I'd have to use this today. Anyway, so where are we? We're day 13. So the way IndexedDB works with this whole cursor concept is first you get an index, and it could be the primary key path. Or it could be this author ID one that we've made, this index author ID. And probably a way to visualize this is once you do this, you've got the whole table over here. And once you've fetched this index, what happens is it puts you on a track. Well, track's probably the wrong word, but anyway, let's, it's not super straight, but who cares? All right, so let's say we're on these tracks. And so we have four, so this is the whole table, and there are rows in each of the table. And what happens is the first time you do this query, you end up with a cursor, you end up here. And then you have to tell it, all right, I'm done with this one. Now take me to this one. And then to this one. And then to this one. And the whole thing is because we've got a filter on this key range, it might be, because we've got that key range sort of argument, it might be that this one doesn't actually count. So what actually happens is, say this one and this one are meant to be ignored. So what happens is when you hit next on this one, it jumps to this one. And then when you hit next on the final one, it takes you to a certain state. I can't remember what that state is, but that's the state that says, all right, you're done. You don't need this cursor anymore. You can now resolve with the full result. So we have to step our way through the database, putting items where they need to be as we step through it. So let's do just that. If we've got this concept of a cursor, so the cursor is ev.target.result, and we cannot resolve yet, not here, because we do not actually have everything we need. So we need to store our results somewhere. So let's do them up here, just for argument's sake. We'll do them here. And what we'll do is from here, we'll have to decide whether to continue on or whether to return those results as we've got everything that we need. And this is where, again, we need to look at what our sort of options are as we work over this cursor. So we've got an API on it that lets us call continue on it. So when we call continue, it takes us to the next thing. And I believe that event will fire a second time when we get to the next thing. But I'm not 100% sure on that. We'll find out real soon. Yeah, so we've got continue, and we've also got the ability to update items using this cursor. And that's exactly what we're going to do. So we're going to have results, and we're going to push cursor, and I'm just going to type this. So as IDB cursor with value. So that way I've got the cursor types here. So the value itself is going to be our result. And that's going to be an array of any. So we need to, that's going to get us through it for a little while, but eventually we'll end up in some sort of error where we're not able to carry on. But for now, I'm just going to call continue here and then just see what happens, because it might be that like this will just continue on forever and break and whatever, and that's fine. We want to find out what's actually going to happen there. So it kept on going and then eventually ended up as null. And that's really key right here. Cursor is null. And then, so what actually happened there is not that the value was null, but rather the cursor got to the end. Because you can see here, that's, oh no, that is, that's right. So the cursor came back as null, which meant we fell off the edge of our table. So we ended up at this spot, right here. We fell off the edge of our table or our store or whatever you want to call it. And then we needed to do something proper at that point. We didn't do something proper. Instead, we blew it up. We tried to call something on cursor, and that's when we had this error. But I mean, we can fix that, can't we? So it's a case of going, well, if ev.target the result, then we have a value. We have a cursor. We have not fallen off the edge of the world. So we do this, and we continue. But if we do not have a result, then that means we are now at the end of our process, and now we can resolve with results. And that'll just terminate like that, because it doesn't, once it resolves, then it passes it on. Okay, so this might actually be enough to get the job done. Let's just console log query end, query definition, and then what's the last one? Results. So now it worked, and this time you can see that the query end, so here's the definition, it was store and had that first filter, and then we had an array of all the objects there. So theoretically, all we need to do now is update this this view. Where is he? Authors. Here we go. So we're going to update this view to actually make use of these authors, and I'll pretty much just copy paste from here. No shame in that. No shame at all. I want to get this done, and I want to get it done fairly quickly so that we can carry on, because remember, this is all just demonstrating the point. This code will literally get thrown away once we build the real app. So we don't want to spend too much time on it. Let's see. Where am I? Here we go. Yep. So we've got the view here of authors, of an author. We want to get the article, and at the moment it's going from appstate.content.articles. What we actually want to do is we want to filter on all of those. I mean, technically we could do this and then we could filter on them. Eventually we'll figure out a better way to do this, but for the moment we're taking all the articles and then we're filtering on them based on whether they're actually a article we want. So if return article dot author ID equals author.id. It's unfortunate that we have to do this query twice, but of course there might be data in here that has all the other authors. So we need to, all the other articles. So we do need to do this in order to make sure that they don't come through like that. Right, so anyway, we'll throw in this unordered list underneath and chuck in articles render. And we've got ourselves some information. What's that comma doing in there? Did I put that in there? Oh, right. It's mapping them. I got to join them. Just like that. And then we should be good. Yes, we are. Okay, so now we have these two articles. I can jump back and let's say I take a look at Joe Blogs, rather. I've got them there. So what else could we do to add to this to sort of make it nicer? Maybe on the article pages or the entry pages, they are here. Let's say we link the author as well. So we'll make that an ahref. We'll get URL using route stack and entry, author, and ID is author.id. I don't want to do a line break there, I'll just leave it. So if we do that now, we should have a link for James Blogs, James Rakic, same deal, and Joe Blogs. So you can see there we're starting to get our data to sort of have some sort of relationship. And I mean, it might be, the interesting thing about joins and stuff like that is because we don't actually want our data to be super, super complicated. Like this could actually get us a long way. All we need to do is deal with other aspects of our key range. And maybe it makes sense to talk about how those key ranges would look, even if we don't put them into practice. Like how would we deal with the remaining sort of key range aspects, right? So let's say, because we've only got 5 minutes left, I'm not going to do too much more. But let's say in the query, in query.ts, let's deal with other cases. And we could do this with a switch, but I'm not gonna, just for anyone who's gonna complain or anything like that. So greater than, we'll just do GT, okay? This is, in the context of a lookup, it's pretty clear what we're doing. And let's look at our IDB key range again and see the different methods that we have available to us. So we have these bounds and these lower bounds and these upper bounds. Okay, so how about if we return for greater than, it's IDB key range, and this would be a lower bound. Yeah, that would be the lower bound. So for things greater than this one, and that true there is to say that it's not inclusive, as in it has to, so this one, it can equal y, but whereas this one, it can't equal y. So we'd have def.value and then true here for greater than. And then if we truck on through, we can implement greater than equals with the same thing, except without that truism. All right, next up, lower than. And that would be an upper bound. And then we've got within, which is a bit trickier because it requires two values and not just one. So that would be, yeah, if we have greater than or less than. And the unfortunate thing is we also have essentially things that just have to be done without this, right? That have to be done with the main index and no key range, because if they were done with a key range, then they would just break. Yeah, if they were done with a key range, what would happen to them is that they would end up like they just end up being too complicated or whatever for the system. So what ends up happening in those cases is instead of you using the key range to filter, what you would do is go for some sort of test here. You just go, all right, if sort of, here we go. If cursor dot value, you have some sort of function passes test or something like that. If cursor's value passes test, then you would then put it in here. Otherwise, you just continue on. And that way you can sort of do something more complicated than what this key value system allows. But that's all we're able to do with the key range concept here. Now, just to be clear, like I did bring it up a little while ago that like if you key against something that doesn't allow you to do this sort of thing, like let's say we keyed against full name, it shouldn't let me do this because I haven't actually created an index for it. I didn't freak out. Oh wait, I didn't go on the auth. There we go. So here we go, not found error. The operation failed because the requested database object could not be found. For example, an object source did not exist but was being opened. So that wasn't the actual error though. The operation failed wasn't because of that, but because we were referencing something that we didn't have a key for. Let's say we test against, in articles, let's say we test against not the author ID, but the title. I mean, that might be something that we want to test against eventually, right? But again, that's going to come back as an error. Now, it wouldn't come back as an error if we created an index for it. So say we wanted to search against it. Let's say we wanted to do that. Well, we could do articles, and then add an index for it called title. And then that query, I mean, it wouldn't match anything, but it would work, right? So I will clobber the database and then make sure it rebuilds. So now you can see that that didn't actually fail. I mean, it didn't get anything, but it didn't fail either. And that's the nature of indexes. Realistically, you're in a lot of cases, I just make indexes for nearly every field because you never know when you're going to run queries against them. It just makes sense to. I'm pretty sure most of the database layers, like if they feel like a particular field type can be queried against, they're going to put a index on them just by default, just in case. Right. So anyway, we'll fix up this query, put it back onto author ID. done. Okay, so what have we learned? What have we done? Well, we've started our little query syntax. We're just gonna go with a simple filters concept for now, and we'll examine this eventually, because there might be a case where what we want to do is actually exclude particular things, and you'll notice that the concept of exclusion does not exist in the IDB key range concept. So again, that is one of those cases where immediately we're going, all right, we can't actually do a key for this. So it's something like if def.exclude, then immediately we probably return null, right? Like we can't do it. So we'd have to return null. And then there's other things down here where we're going to have to return null. And then for any of those cases, if we're not returning a key range, then that means that those null returns then have to be dealt with in some way. So let's be explicit here and say that this could be an IDB key range or null. And we'd have to deal with those null cases. In those null cases, what we would do, and I may as well follow that thought down to its logical conclusion. So if we don't have a key, and we don't have the key, for example, if we don't have a key range, there is almost no point in trying to go down this route. And in fact, what we can do is let store request here. So if there's no key range, there's no point in doing that stuff. What we'd instead do is we take the store and just open a cursor on it. So we go index.openCursor. Store.openCursor rather. And then just do our thing with that. Because this is the thing, like we don't, once we do that, then we have to do something with the initial filter here. So here's where filtering logic would go. And it would be just done with pure JavaScript. We just figure it out, build the query, all that good stuff. So this leaves us in a place where we're able to sort of work through this this query language and build it up further. And eventually, we'll just have to work through all of that stuff. We just have to figure it out, what it is, what filters to apply. But that can be a series for next episode. And I've already thinking of a way we could do that. It'll be pretty straightforward, and we'll just have to work through it and get our we'll just have to work through the concepts and build it up from here to there. So yes, we have our queries, and we have something to use there. And next stream, what we'll do is we'll focus on we'll build something to just delete the database every single time we roll in, and then initialize it for us, because that's starting to get to be a bit of a pain when we're updating things. And then we'll build some JavaScript logic for this, maybe add some publication dates to all of these articles so that we can do some sort of time-based stuff with them. Because while I don't want to completely make this query language completely featureful, like have every single thing that we can possibly do with it, I do want to work through it to the point where I know it's going to be usable for all the basic cases, and then we can just improve it as we need to. Yeah, that's pretty much going to cover it. So I'm going to crack through this. If there's any questions, please fire them at me. Otherwise, I am going to commit all this work, tag it, and call it a day. So we implement it, implement start of query, query interface. I won't call it a query language, it's really the wrong thing to call it. Added author page for testing. Oops. All right. Git tag day 13. Push them up. And we'll push the tags as well. All right, well, that's pretty much it from me. Thanks for watching. No questions as it stands. So I'll be back on Wednesday, 8 p.m. Australian Eastern Standard Time, where we're going to carry on with this project of building out this IndexedDB layer so that we can work with it, depend on it, get to know it and love it, because really we're going to have to get used to it if we've got an offline app, because it's really the only way we're going to store our data in a sane way that's going to work well for us. Anyway, that's it from me. Have a good one.